Hello my dear EAPCET aspirants, welcome back to NEET World. So this is our day 3 of EAPCET series. So in this series of videos, we are fully focusing on EAPCET preparation for 2026 EAPCET, right? So I hope you are following our channel and you are using this channel at most preferably. Okay, so if you are preparing for EAPCET, whether you are a BPC student or MPC student, you are at the best platform. This platform will give you very quality of content where we will be focusing on important topics as well as PYQs related to those important topics. Okay, so once after watching this video, you can try few more PYQ questions so that you will get more confidence on the topics that we have discussed here. Okay, so I hope you have watched last video on mole concept, very basic concepts of chemistry, like very small topics, like I can say very basic here. Okay, and I have solved few questions related to those basic concepts also. How can we approach the numericals? We have discussed in the last session, right? So today also we will be discussing few important topics and PYQs related to those topics. Okay, so just stay tuned with this channel so that you will get daily updates from us. Okay, for example, based on yesterday's discussion, just look at this question from 2023 paper. See here, it is saying which one of the following has same number of atoms as there in 6 grams of water. So it is very simple. Whenever they are asking number of atoms, number of particle or quantity of substance, you just think about number of moles, N. Okay, so first of all calculate number of moles here so that you will get some clarity. See, by finding number of moles, how can we solve this question? See, 1 mole of any substance will contain Avogadro number of particles, we know, Avogadro number of that molecules, we know. If I say 1 mole of water, it will be having Avogadro number of water molecules, right? They are asking number of atoms here, number of atoms in water, how many are there? See, first calculate number of moles, okay, so that you can multiply that number of moles into Avogadro number. This will be the calculation if they ask for number of water molecules, but here they are asking number of atoms. So multiply it with its atomicity. Atomicity means what? Number of atoms in the given formula unit. See, in water molecule, how many atoms are there? 3 plus 2 plus 1. So total 3 atoms are there now. So take atomicity as 3. That's it. Okay. So look at here. First, number of moles of water are how many? 6 grams. Given weight is 6, and its molar mass of water given weight by its molar mass. Okay. So how much? 18 for water molecule, right? Water molecule here they have given. So it means it will be 1 by 3 mole. So we got 1 by 3 moles. So 1 by 3 moles I can write 1 by 3 into 1 mole of any substance contain Avogadro number of molecule, right? Multiplied with what is the atomicity of water? I told you 3. So because they are asking number of atoms here. So total number of atoms are how many now? We got number of atoms in 6 grams of this water molecule given quantity is having Avogadro number of atoms. Okay, hope this is clear. So now look at the options. We need to verify the options which are having same number of atoms. Very simple. Look at this option here. If I say first option, if I consider, see 0.4 grams, 0.4 by atomic number of helium is 2 and its mass number is 4, right? So mass number is 4 means 0.1 by 4 into Avogadro number. It gives number of helium atoms because its atomicity is 1 only, that's it. Okay, so it will be 0.1 into Avogadro number, but we require 1 Na, that is here it is 0.1 Na, so this is not the correct one. Next, check for this option C so that we will get direct answer here, because I know this. By looking at the question we can answer this. See, 1 gram means given weight is 1 and the molar mass of hydrogen is 2 multiplied with what is the atomicity here we have for H2. So this 2 is indicating the number of atoms here, that is called atomicity, and multiplied with Avogadro number, that's it. So here the number of hydrogen atoms here as Na, that's it. So we got Na number of atoms in 1 gram of hydrogen as which is equal to in the question, that is 6 grams of water molecule. So our option C will be very suitable answer for this question. Hope I have covered this very clearly without having any confusions, right? So if this is clear, just click on the like button, right? Yeah, so let's go little more deeper. Yeah, look at here, this question I have solved in the last class also. Now you can try this question. If you are unable to solve this, just go back to the previous video, that is day before yesterday's video, and watch it. Okay, right. Next, look at this question. This is also very interesting here, very basic and interesting. See here, 6 grams of urea and 9 grams of glucose were dissolved in 35 grams of water. They dissolved in 35 grams of water. Okay, that's it. The mass percentage of urea and glucose respectively. So they are asking percentage of composition. Percentage of composition. See, percentage of composition of a particular substance if they ask. See, percentage of a component if they ask. Very simple, you can solve this very easily. Just look at here. Component if they ask, take weight of that component by total weight into 100. Okay, so look at here, they are asking percentage of urea in this mixture. So what is the percentage of urea? You can take percentage of urea equals to weight of urea. How much weight of urea given? 6 grams in the solution taken. Okay, and what is the total weight of this mixture? Water plus glucose plus urea here is 50 grams, right? See here, 6 plus 9, 15 plus 35, 50. So total weight is 50 grams. Okay, it means weight of urea by total weight of this mixture into 100. That's it. Okay, so now just look at here. This will be 2 times. So what is the percentage of urea? 12%. Okay, now similar to this, you can able to find percentage of glucose also. So what we can take here, percentage of glucose is equals to weight of glucose, that is 9 grams, and total weight is 50 multiplied with 100, that's it. So this will be 2 times. So we will get 18% glucose here. Hope this is clear. So we have 12, 18, option C will be perfect answer, right? Hope this is also clear, and if these things are clear, just click on the like button and you can express your concerns or the way you are expecting from our side. You can write in the chat box, we will be looking into it. Okay, right. Let us move forward with few more questions. See here, the total number of protons in 10 grams of calcium carbonate. Okay, I have solved this question in the previous session itself. You can try this. If you are unable to solve, you can watch the previous session video. Okay, right. Look at this question. Done this. Next, look at here. We have a formula given. The formula of a metal oxide is M0.96O1. Okay, the fraction of metals exist in +3 and +2 ions in the oxide are respectively. See, similar type of question were appeared in 2022 JEE also. Okay, so we can solve this very easily. In that exam they have given with iron, Fe 0.98 O100 something like this. They have mentioned O1.00 they have mentioned, and they are asking percentage of +3 ions, +2 ions in the exam. So let us make this clear here. See, instead of taking this in the decimals, just multiply this equation with 100, so that we will get M96 O100. So this will be the formula, just for making ourselves like simple while solving. That's why I am multiplying with 100. Okay, so now out of this 96, some of them are with +2 oxidation state. Let us say X number of metal ions are with +2 oxidation state, and 96 minus X number of ions are with +3 oxidation state. Or you can take in the reverse manner also. This as +3, this as +3, and this as +2. Whatever the way you are convenient, you can take it. Okay, the total will be equals to 96 only now, plus x minus x here if you remove. Okay, so it means, see, when oxygen is combined with metal, so definitely here metal will be forming metal oxide, because they mentioned here it is metal oxide. So in oxide form, oxygen atom will be, one oxygen atom will be having charges -2. There are 100 oxygen atoms here, so it means total negative charge on this oxygen will be, total negative charge here will be -200 I can consider. So total positive charge will be +200. It means what I am taking here, there will be 3 ions, there will be x number of ions with +3 charge, and there will be 96 minus x number of ions with +2 charge, which is total, the total charge here will be equals to +200, that's it. So by simplifying this, you will get one of these 4 options. Okay, try to simplify this. See, 3x plus 2, 1, 8, 192 minus 2x equals to 200. Okay, right. So from here 3x plus 2x will be x, which is equals to 200 minus 192, this will be 8. So how many +3 ions are there here? 8 +3 ions are there. So 8 +3 ions means they are asking percentage of +3 +2 right now. So if they are saying percentage or fraction, you can take out of 100, 8 are +3. It means what is the fraction here? 0.08. Similarly, out of 100, 8 are +3 means remaining 92 will be +2 ions now, that's it. So 0.92 will be the another option here. So here we have 0.08, 0.08 and 0.196 means that is 0.92 I can say now. So our option B will be very suitable answer for this particular question. Hope this is also clear. See, we got the options here, those are there. Okay, right. Let's move forward with few more questions. Percentage of composition we have discussed in the last class. What I told you, percentage of composition, there are 2 types. One is by mass, another one is by mole. By mass means you should take weight of the component by total weight into 100. By mass means number of moles of component by total number of moles of all components into 100. So I have given an example of methane while explaining this, right? So we'll see some questions related to this based on previous discussion. Look at this, the percentage of nitrogen in the urea. See, what is the formula of urea? What is the formula of urea? So we know C double bond O, NH2, NH2. How many nitrogen atoms are there here? 2 nitrogen atoms are there. Percentage of nitrogen they are saying. Percentage of nitrogen if they ask, take weight of that nitrogen atom by total weight into 100. So what is the weight of nitrogen atom? There are 2 nitrogens, each one will be 14. So you can take 2 into 14, and total weight of this molecular formula urea will be having, see, 28 for 2 nitrogens and 4 hydrogens are there, plus 12 plus 16. So the sum will be equals to 60. Okay, so 28, 30, 40, 20, 60. Okay, so you can take 60 into 100. Okay, and the next here, okay, so here it will be 140 by 3. So 140 by 3 here will be approximately, we can see 3 4s are 12, we are having 2 here, 6 are 18, so 46% we have first option now, so that will be our option here. Hope this is also clear, right? Let us move forward with few more questions. Again, see, I have discussed about empirical formula, molecular formula. So what is the difference between empirical formula and molecular formula? See, molecular formula gives exact number of atoms present in the given given molecule. For example, if I ask what is the molecular formula of glucose, you will be saying it as C6H12O6. So look at here, an empirical formula represents simplest whole number ratio of various elements present in a compound, whereas molecular formula shows exact number of different type of atoms present in a molecule of a compound. See, in this glucose formula, in this compound we have 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. This is the exact representation of each atom present in the given compound, right? So this represent molecular formula. And if I ask empirical formula, just take the simplest ratio that we can get from this. See, I can say C1, H2, O1 and taking 6 as a common. Okay, so the simplest way of representation is there now, C1, H2, O1. This is called its empirical formula. Okay, we got two types, one is molecular formula, empirical formula. So now what is the relation between empirical formula and molecular formula? See, molecular formula equals to empirical formula multiplied with some number n. So that number n depends upon what type of formula we are taking. For glucose, the n will be here 6. Okay, now you can take for acetic acid, if you take CH3, COOH we are writing. How many carbons are there? 2. Okay, how many hydrogens? 4. How many oxygens? 2. So what is the simplest formula here we will get? C, H, C1, H2, O1. And n value here will be the number, whole number which is simplest whole number here, it will be 2. Okay, so now if you observe the empirical formula of glucose and empirical formula of this acetic acid are having same formula, right? C1, H2, O1. So this will be the empirical formula of glucose and acetic acid. It means empirical formula might be same for different compounds also, but molecular formula will be different depending upon the compound to compound. Okay, so here what is the relation between empirical formula and molecular formula in case of acetic acid? So molecular formula will be equals to empirical formula multiplied with 2. Okay, in case of acetic acid, so that we can simplify in this way, empirical formula into n gives molecular formula. Hope this is clear. So where n is a simple whole number, may vary from 1 to 1, 2, 3, so on like that. Okay, now look at the question from EAPCET related to this empirical formula and molecular formula. See, concept plus basic questions, then next PYQs. These are the 3-step way we can make ourselves clear and well prepared for the exam. Okay, so just follow these 3 steps. Concept first, clear the concept, look at the applications and solve some basic questions first, so that you will gain or boost your confidence, and then next go through the PYQs. That's it. These are the simple 3-step way to tackle your EAPCET exam. Okay, look at here. The empirical formula of a compound is C2H5O and its vapor density is given as 45. What is a molecular formula? This is the empirical formula they are saying, and what is a molecular formula asking here. Simple question here. There is a relation between vapor density and molecular formula. See, vapor density of a compound will be equals to its molecular weight divided by molecular weight of hydrogen. What is the weight of molecular weight of hydrogen? It is fixed now, that is 2. That's it. Vapor density equals to molecular weight of compound they are saying by 2. Why this is 2 here? That is a molecular weight of hydrogen. Okay, we are comparing molecular weight of that particular component to the molecular weight of hydrogen. That gives the vapor density. Okay, so here vapor density mentioned as 45. So 45 multiplied with 2 gives molecular weight of the compound. So what is the molecular weight of the compound? 90. Okay, so now you got molecular weight of the compound now. Similarly, from this formula, from this empirical formula, you will get empirical weight. See, 2 carbons means 2 into 12, that is 24, plus 5 hydrogens plus here how much? 1 oxygen atom. So 1 oxygen atom means 16, right? So 30, 40, 45. What is the empirical weight formula? 45 grams. Molecular weight formula 90. So from this relation, molecular weight is equals to empirical weight into N. So N gives from this particular formula as N molecular weight by empirical formula weight, that is 90 by 45, which is 2. So what is here, the simplest whole number we got 2. So multiply this empirical formula with 2 to get a molecular formula. So C4H10O2. So where do we have C4H10O2? Yes, option C will be perfect answer here. Hope this is also clear, right? If the things are clear, just watch the video completely, finish up your preparation from the first chapter, and the next we will move for the second chapter. And before going to the second chapter, you just solve some PYQs related to this particular concepts of first chapter. Okay, and if you are not having any PYQs, so you can just go through the online media anywhere, or you can watch our website, or you can join our Telegram group, so that our team will be providing free PYQ sessions, PYQ questions of each chapter in the Telegram group. Okay, right. And even if you have any doubts, you can post in the Telegram group. Okay, right. And next, look at this question again. A compound X contains 32% of A, 20% of B, and remaining percentage of C. The empirical formula of this X, again look at here, see, a compound is made up of A, B, C, having 32% A and 20% B, and remaining percent is C. So it means if ABC is making 100%, 100 minus A plus B gives the quantity of C, that is 32 plus 20 is 52. So remaining will be 48. The quantity of C here I can take 48, that's it. Okay, and what is a formula, or what is the empirical formula that can be made from this ABC they are saying, which is indicated with X. So now out of these 4 options we need to choose one. Okay, look at this. So we have like this now. So divide these weights of that particular ABCs with their atomic weights given in the question itself. So 32 divided by 64. Why? Because molecular or atomic weight of that A is 64 given, and atomic weight of B is given as 40 here. Atomic weight of C is given as 32 here. Take them. Okay, so take the ratio here, will get 1 by 2, and here also 1 by 2, and this will be 3 by 2. Okay, so you got A 1 by 2, B 1 by 2, C 3 by 2. So what will be the simplest way we can represent this? A, B, C 3. A, B, C 3, because 1 by 2, 1 by 2, 1 by 2 I can remove it. So this will be the empirical formula of the given compound, A, B, C 3. Okay, so option 3 will be the best answer here. Hope this is also clear, right? So different models we have covered that are related to percentage composition and empirical formula. Now we will be looking into stoichiometric calculation. So stoichion means what? Stoichion means measure of elements in a given reaction, how the elements are combining to form products, and what is the quantity of product formed, that can be calculated using this stoichiometry. Okay, very simple. See, it is used for calculation of number of moles, masses or volume of reactants products that are chemically combined to form products. So it means I am saying for formation of water, H2 plus O2 gives rise to H2O if I write. So how many moles of H2 combined with oxygen to form water? For example, 1 mole of H2. Here what is this mole I am saying? See, the number which I am indicating here, stoichiometry number, this, what is the coefficient here I am writing, that is called the stoichiometry coefficient of that particular species. Okay, so if I take 1 mole of H2 here and half mole of O2 will combine to form 1 mole of H2. So how we are doing this? See, whatever the number you are taking here, no issues, take, but then the number of elements product side and number of elements reactant side must be conserved. For example, hydrogen atoms at the reactant side are 2 into 1. so 2 hydrogen atoms are there. Product side also must be 2 hydrogen atoms are present. So that is called a balanced chemical equation. Okay, first of all write the balanced chemical equation. As per the balanced chemical equation, we can able to find theoretical yield of this product formed. It means I can say 1 mole of H2 combined with 1/2 mole of O2 to form 1 mole of product, that is water here. Or in the simple manner, instead of writing it as 1/2, just multiply this equation with 2, so that if we multiply with 2, we will get 2 moles of H2 combining with 1 mole of O2 forming 2 moles of water. So this is what mole ratios, these are what mole ratios, okay, or mole relation. Okay, instead of saying moles, we can also calculate this in terms of grams also. We know 1 mole of hydrogen can also be written as 1 mole of H2 can also be written as 2 grams, because molar mass of hydrogen is 2 grams now, that's why I am taking 2 grams. Instead of saying 1/2 mole of O2, I can say 1/2 into what is the molar mass of oxygen, that is 32. So you can take 16 grams. So you can say 2 grams of H2 are combining with 16 grams of O2 to form 1 mole of H2O, that is 1 mole of H2O is nothing but 18 grams now. So 18 grams. See, if you observe, the whatever the quantity of product, that is 18 grams, will be equals to the quantity of reactant side. See, 2 plus 16, that is also 18 now. So total mass is conserved. This is what law of conservation of mass in the chemical reactions. Okay, generally chemical reactions will follow law of conservation of mass, and law of conservation of mass I can say, and in similar to that in that manner I can say atoms also must be conserved during the chemical reactions. Okay, right, these are the 2 things you need to remember first. Okay, next, if I say I want to produce 9 grams of water, how much? 9 grams of water, so that how many grams of H2 and O2 should be taken here, tell me. See, for 18 grams I am taking 2 grams and 16 grams. For 9 grams, here just divide these equations by 2 now, because here also I did that by 2 means 9 only now, here also by 2 means instead of taking 16 grams you take here 8 grams and take here 1 gram, that's it. This produces 9 grams of water. Hope this is clear, right. So what if we take this something like a random amount means what if I take this as 2 grams and this as 18 grams, if I am taking this as 18 grams, and how many grams of product will be formed, tell me here. See, whatever the quantities you are taking, just relate these quantities to the balanced chemical equation quantities. Either you relate it to the number of moles or the weights comes from that number of moles. See, for every 2 gram as per the balanced equation, for every 2 grams we required 18 grams. We required 16 grams. Right now 16 grams of oxygen is required, so that it will produces 18 grams. Here 2 grams of hydrogen is given. For every 2 grams as per the equation what we required, 16 grams are enough, but here we have 18 grams. Out of this 18 grams, 16 grams will be react with these 2 grams and remaining 2 grams will be remained excess. What I am saying, remaining 2 grams will be remains excess, and whatever the excess quantity is there, that will be remained unreacted in the reaction. Okay, so it means the one which is in the excess quantity in a given reaction is considered as excess reagent. What is that? Excess reagent. They will ask in the exam, in the given reaction identify the excess reagent and limiting reagent, and one which is having lower quantity, that will be considered as limiting reagent. And always remember, our calculations must be carried using limiting reagent only. First of all, you need to identify which is excess reagent, limiting reagent. After identifying, our calculation, that is amount of product formed, will depends upon limiting reagent, because it is in the lesser quantities now. So if one substance is lesser quantity, how that product will be formed in the greater quantities. So it means the one which is in the lesser quantity, that will decide how much amount of product should be formed in the reaction. So for every 2 grams, as per the equation, for every 2 grams 18 grams are formed here. So here also 2 grams are there. So as per that 18 grams will be formed here. Okay, for understanding, I hope it is clear now as of here. Now again I will be giving you few more questions on this, so that you will get complete clarity. So look at this question. How many moles of ammonia are produced by 5 moles of hydrogen? So this is again 2020 question. See, in our channel we do not prefer to discuss trash. We will only focus on concept that are very important for exams. Okay, so if you are really preparing, if you are seriously preparing for your preparation, just click on the subscribe button, and if there is any of your friends who are also preparing seriously for this EAPCET, JEE or NEET, you can share with them so that they will also get benefited from this. Okay, and you can share your feedback in the chat box. We'll definitely look into it, and we are going to cover them in the upcoming sessions. Okay, yes, look at this. How many moles of ammonia are produced by 5 moles of hydrogen? See, ammonia production will be happens through Haber's process now. So for this purpose we require nitrogen and require hydrogen. Okay, that's it. Does this equation is balanced? No. First of all, you need to write the balanced equation. See, 2 nitrogens at reactant side, definitely there should be 2 nitrogens at the product side, and total hydrogens at the product side is 2 3 is 6. So reactant side also it should be 6. That's it. So we got 1 reactant side also it should be 6 hydrogen atoms. Okay, so we got 1 mole of H2 reacting with 3 moles of H2 forming 2 moles of product. Okay, instead of saying mole, we can also say in terms of their weights also. Instead of saying 1 mole of N2, I can say 28 grams of N2 also. That is also correct only. But as per the question given here, they are saying in terms of moles only. So no need of taking that. So take 1 mole of N2 reacting with 1 mole of H2 forming 2 mole of product NH3, right? After this, how many moles of ammonia produced by 5 moles of hydrogen? So if you take 5 moles of hydrogen, how many moles it is produced, product is formed, they are asking. Simple, use the unitary method. See, for every 3 moles produced ammonia is 2 moles. For every 5 moles produced ammonia will be x moles consider. Find the value of x. So value of x can be taken as, just use the unitary method, 3 into x 3x here, and 5 into 2 10, you can take it like this. So multiply this 2 and multiply this 2. I need the value of x, that is 10 by 3. So this will be nothing but 3 times 3 3 is a 9, so 3.33 will be the answer. So option D will be your answer for this question. Hope this is also clear, right? Let's move forward. Look at this question. Calculate the amount of CO2 produced when 32 grams of ammonia or 32 grams of methane is burned with sufficient amount of oxygen. Very simple. I hope you know the formulas, they are mentioned here, like CH4 means what? Methane, and for combustion of methane what we require? Oxygen, that is mentioned as sufficient amount. Okay, right. Giving CO2 gas upon complete combustion of methane or hydrocarbons produces CO2 plus water. Okay, so I hope you know how to balance the given chemical reactions like combustion equations and all. Okay, now look at this. How many carbons are there at the reactant side? 1 carbon, right? So product side must be 1 carbon, that's it. 1 is inserted there. How many hydrogens here? 4 are there. Product side also 4. Already 2 is present, so multiply with 2, that's it. So hydrogens, carbons are balanced. Now look at the oxygens here. 2 oxygen atoms here and 2 oxygen atoms there. So 4 are there, 4 oxygen atoms are there. Here only 2 oxygen atoms. So multiply this with 2. So 2 total equation is balanced. After balancing this equation, so take their mole ratio, 1 mole of methane combining with 2 moles of oxygen forming 1 mole of CO2 and 2 moles of water, that's it. Now they are saying amount of CO2 produced when 32 grams of methane is burned. So it means just consider here 1 mole of methane as per the equation, as per the balanced equation. 1 mole of methane producing 1 mole of CO2. That's it now. So it means instead of saying 1 mole, I can say 16 grams now, because molar mass of methane 12 plus 4. So 16 now. So molar mass of methane is 16. So in the place of 1 mole, I am writing 16 grams. So for 1 mole, product formed is 1 mole. So for 16 grams of methane, product formed will be 44 grams of carbon dioxide. Why 44 grams? For carbon it is 12, for oxygen it is 32. So total sum will be 44. That's it. 44 grams of CO2 is formed. Hope this is also clear, right? So here they mentioned 32 grams. So they doubled this quantity. 16 grams giving 44. 32 grams will give how much? This is doubled. 32 twos, 16 twos. Here also you can double it. 44 twos, 88. So 88 will be your answer here. So option C will be perfect answer for this question. And now, can you answer me what is the quantity of water formed in this reaction, or in this data given now? Use the data and tell me amount of water produced in the reaction. I will be looking into your answer in the chat box. Okay, I will definitely reply on that. If you answer it, whether it is correct or not, no issues, you can try to answer that in the chat box. Okay, right. Next. Look at this assertion reason based question here. Look at this assertion reason question. The mass of products formed in a reaction depends upon the limiting reagent. Yes. So there are two quantities in a chemical reaction. One is limiting reagent, other one is excess reagent. So our calculation should be must done with respect to limiting reagent to find amount of product formed. So this is correct. The mass of products formed in a chemical reaction depends upon limiting reagent. Yes, assertion is correct. Reason: limiting reactant reacts completely in the given reaction. Yes, limiting reactant always react completely now. Product like excess reagent only will remains extra unreacted, but limiting reagent 100% completion takes place, right? So both assertion, reason are correct. So both assertion and reason are correct, and it is correct explanation also, right? Right. Next. So can you answer this question? See here, H2 plus Cl2 forms 2 HCl. HCl. So for this purpose, we require 1 mole of H2, 1 mole of Cl2 gives 2 moles of HCl. So 1, 1, 2. Okay. After this, look at the equation. This is a balanced equation. As per that, the balanced stoichiometric coefficients are like this. Okay. After this, given 5 moles of H2. So given 5 moles of H2 and 7 moles of Cl2 combined to form X moles of HCl. The value of X, we need to answer value of X. Identify limiting reagent, excess reagent in the given reaction. Okay, very simple ma. See, for every 1 mole of H2 we require 1 mole of Cl2. It means for every 5 moles of H2 we require only 5 moles now, but they have given 7 moles. So out of the 7 moles, 5 moles will be reacting with this H2 and 2 moles will be remained excess. So I can say Cl2 is our excess reagent and H2 is our limiting reagent. Hope this is clear, right? After this, our calculation should be taken with respect to limiting reagent only. So it means for every 5 mole of H2, we are getting 1 mole, 2 moles of HCl. Okay. So it means for every 5 mole, see, for every 1 mole, we are getting 2 moles of HCl. So for every 5 moles, it should be twice now. For 1 mole, it is 2. For 5 mole, it should be twice of it. Okay. So it will be 5 into 2, that is 10. So what is the value of X here? 10 moles. That's it. We identified limiting reagent, excess reagent, and we also calculated quantity of this HCl formed in terms of number of moles. Okay. You can do this in quantities expressed in weights also. 10 moles we got now. So After this, if they ask that in terms of weight of HCl formed, you can take 10 moles into molar mass of this HCl. What is the molar mass of this HCl? For chlorine it is 35.5, for hydrogen it is 1. Okay, so you can take 36.5, that is 36.5. So what is the weight formed here? 365 grams. So this is how you can able to answer based on the questions they are asking if you are clear with the concept. Okay, so now these are very basic that must be known for everyone for any exam you might be preparing. Okay, right. Next, there is one more concept called percentage of yield. So what is this percentage of yield? See, during chemical reactions, we know along with the products some byproducts will also be formed right now. So it means they are saying percentage of yield here now. So for example, we are saying H2 plus O2 gives rise to H2, I am saying here. Okay, so as per the balanced equation, for every 1 mole of H2 will get 1 mole of H2. This is what the theoretical calculation, amount of product formed. But when it comes to practical data, most of the reactions will not be having same quantity as that in the theoretical yield. It means experimental yield will be observed to be lower than the theoretical yield. Okay, now the ratio of this experimental yield to this theoretical yield is considered as percentage yield of that particular reaction. So what is the percentage yield formula? Actual yield or the experimental yield by theoretical yield into 100. For example, here you can understand for formation of water using this reaction, let us say if I take 10 moles of hydrogen, it will be forming 10 moles of water. This is what based on the chemical equation, balanced chemical equation. So I can say this is a theoretical calculation. What is this? Theoretical calculation. But when I perform the experiment, when I did this experiment to produce this water, we got only some 8 moles of water is formed. Instead of 10, we got only 8 moles. Experimentally, it was only 8 moles. Then remaining 2 moles were not formed. It means our expectations are 10 moles, but formed are 8 moles now. So in this case, I can use a term called percentage yield to express how much quantity of product formed. See how much it is formed, 8 moles na 8. For how many moles? Theoretical yield calculation will be 10, right? But calculate experimental yield, it is only 8. So 8 by 10 into 100. So you can say this is 80% produced, 80% of product is produced, or you can say percentage of yield for this reaction is 80%. Hope this is clear. Now if you want, just solve this question once. See, for a reaction 2A plus 4B forming 4C, 2A plus 4B forming 4C. Initially 2 moles of AB are taken. See, as per the equation what we have, for every 2 moles of A, we require 4 moles of B, so that it will form 4 moles of C. So given what they have given here, 2 moles of A is given, 2 moles of B is given, is taken, only 2 moles of AB are taken, then 1 mole of C is formed. So they are saying 1 mole of C is formed. Okay, identify the limiting reagent, excess reagent, what is the theoretical yield and what is the percentage yield they are saying. See, what we know here, for every 2 moles of A, we require 4 moles of B. But in the given equation, we have for every 2 moles of A, we have only 2 moles of B. But how much we require? 4 moles is required. It means our B is lesser than the requirement now. It means I can say B is our limiting reagent and this A will be our excess reagent. So our calculation should be done with respect to limiting reagent only, okay, because it is in lesser quantity now. So for every 4 moles I require 2 moles. For every 2 moles of B we will require only 1 mole of A, that's it. Out of this 2 mole, 1 mole will react with these 2 moles of B and remaining 1 mole will be remained excess. Okay, that's it. So what is our limiting reagent? B. So calculation should be done with respect to B only. So for every mole C formed will be 4. For every 4 moles of C is formed. For every 2 moles of B, 2 moles of C should be formed. So what is our theoretical yield? 2 moles. This is theoretical yield. Okay, but practical evidence is saying that only 1 mole of C is formed. So that is nothing but percentage of yield can be taken as experimental yield, that is actual yield, or I can say experimental yield, that is 1 mole, and theoretical yield is 2 moles multiplied with 100. That's it. This is percentage yield, that is 50%. Hope this is clear. How we have identified limiting reagent, excess reagent. After identifying limiting reagent, we have calculated the theoretical yield using the limiting reagent concept. After that, theoretical yield compare with the experimental yield, the ratio will give us percentage of yield. That's it. These are the 3 steps involved in the question. Okay, hope this is also clear, because there will be one question on this percentage yield or stoichiometry related question. In any exam, especially when it comes to EAPCET, you take the PYQs, you observe there will be at least one question based on the stoichiometry calculation, because this is very basic. Like if you are doing a chemical reaction without knowing amount of product formed, what is the purpose of doing the reaction, right now? So this is very basic thing to know for each of the chemistry student. Okay, so try to do more questions on this concept, whatever we have discussed on stoichiometry calculations and theoretical yield, experimental yield, and excess reagent, limiting reagent, percentage yield. These concept based questions, you will definitely have one question in your pocket. Okay, right. Okay, so look at this question. This question I have explained in the last class also. Just try. If you are unable to solve, you just watch the previous live session, that is yesterday's live session. And next, here one more question is for you. 108 grams of aluminum will react completely with how many grams of oxygen? Okay, so for aluminum, oxygen combine to form Al2O3. So first of all, balance this equation. After balancing this equation, how many moles of aluminum combining with how many moles of oxygen and forming how many moles of Al2O3. You find their stoichiometric coefficients here, ABCs. Okay, after finding, just find the relation. Okay, so for 1 mole of aluminum, the weight will be 27 grams. Okay, so how many moles it is? Multiply with that 27, so that we will get weight here. Like that, you can take here 108 grams, so find the relation between them, weight relation you can find, and you will get the final answer. And I want answer for this question in the comment box. Okay, right. Even it is wrong, no worries, I am going to explain. If you answer it, I will look into it, definitely I will answer back to that question. Okay, right. And can you answer this question? The number of atoms in 4.25 grams of ammonia is approximately. You just try to find number of atoms here. So number of atoms, in order to find, you need to find number of moles first. After finding moles, you multiply that with Avogadro number. After multiplying with Avogadro number, that many number of ammonia will be there. Multiply with its atomicity, that is atomicity is 3 here, that's it. So this will give you the one of these 4 options. You can answer me in the chat box. Okay, so till now I have did few some questions. all this whatever I am showing now are for you. Okay, next. Again look into this question. This is also discussed in the last class. You can try this. If you are unable to do, you can watch the previous video. All these questions whichever I am showing here. Okay, right. And how about your IPE preparation? I hope it's going well. If not, don't worry. You just contact us to the WhatsApp number provided below, so that our team will provide you the very important questions of IPE examination. Okay, because exam dates are announced, and if you are really tense about your preparation, you just contact us to the mobile number which is given in the description box. So our team will share you the important important IPE questions. Okay, so from each chapter there are some important questions, right, for IPE. So those questions are segregated by us. So we will be sharing if you contact us through that mobile number. Okay, thank you. Okay, so if you have any concerns, you can just tell me in the chat box. We will be discussing them in the upcoming sessions. Thank you for watching. Stay connected with this NEET World channel. Thank you.